Hello students, I'm thinking to do a video for this is a video about, not chapter 3, it's actually exam 3 review. It is covering chapters 7, 8, 9. So if you start from these concepts, it's I give the review, but you have to know all the concepts. That's the purpose of the exam. But this will help you to do better and more confident for the exam. So you need to know what is Vesper theory that we use oftentimes. Vesper theory is valence, shell, electron pair, repulsion theory. You should have so in the valence shell electron pair repulsion theory mainly talk about the geometries of the molecules. You need to know clearly what is the electron geometry and what is the molecular geometry. You also need to know how to draw the structures of each and every molecule. So if you think about the um, if you think about the shape of a molecule, you need to know the shapes. Example, this says if you want to know about SO3. So let's see how do we know the shape of the SO3 molecule. Let me draw you SO3. So here it is. So SO3. So let's how to draw a Lewis structure first. Before predicting the molecular geometry, you need to know you need to draw the Lewis structure. In order to draw Lewis structure, there are certain steps. You need to identify center atom. Center atom always less electronegative atom. Least electronegative atom goes to the center. And then you count how many valence electrons. What are the valence electrons? Valence electrons are electrons in the outermost shell. Um, Electrons in the outermost shell. So example, sulfur. How do you know how many valence electrons? First, you need to know what is the group number. Sulfur in a periodic table, it is group 6. What is group 6? If you think about the periodic table now, take a periodic table out, see where how the sulfur is group 6. I'm talking only about the main group elements. Think about, like, the group 1 is hydrogen, like that, and then it goes to the um, hydrogen, potassium, and then it goes to the magnesium, calcium, then comes to the aluminum. So now you get the third like that, and carbon, and then nitrogen, phosphorus, and then oxygen, sulfur. So that's what I'm telling. Okay, sulfur is group 6. So sulfur has 6 valence electrons. Obviously oxygen also has 6 valence electrons. So I'm taking sulfur as the my center atom, and then the valence electrons. I know sulfur brings 6. Each oxygen brings 6 into 3. So it comes to me as 24 valence electrons. So I put sulfur and distribute O, 3 oxygens, and I distribute my 24 valence electrons. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now I get an issue. What is my issue? I have 8 electrons in all the outer shells, right? But outer atoms. What are the outer atoms? Let me take another color. Okay, this is a good color. So now all the outer atoms, if you see, have 8 electrons. Sulfur has 8 electrons. No, sulfur has 1, 2, 3, 4, 5, 6. How can I make 8 electron to the sulfur? Sulfur is a bigger element. Bigger element means sulfur is in a period 3 or below. So it can accommodate more than 8 electrons. So sulfur can share double bonds with all the atoms, and then comes to the SO3 structure is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oxygen, oxygen, oxygen. 5, 6, 7, 8. 5, 6. So now this is the SO3 structure. Like that, you need to know how to draw these structures. Okay, So let me get out of this one now. Um, okay, that's good enough now. And then that's how you draw the Lewis structure of a compound. Like that, you need to know how to draw the Lewis structure of other compounds such as carbon dioxide, and you need to know this all this given in your notes for how to draw carbon dioxide, what, and then you need to predict the shape. Let's say carbon dioxide. I'm gonna draw it real fast for the carbon dioxide, and then carbon dioxide, I use the same principle, and this is a carbon dioxide, and I'm asking, okay, what is the electron geometry? Electron geometry is how can I predict electron geometry? I'm looking how many electron domains around the center atom. Electron domains around the center atom is basically groups of electrons. Okay, so I have one electron domain, and sorry, it's not that. This is one electron domain, another electron. So two electron domains around the center atom, it is linear. Always it's linear. Then now I'm getting another one, ammonia. Um, okay, ammonia, NH3, one, sorry. I'm gonna get a new page. Ammonia, NH, 1, 2, 3, 4, 5, 6. Okay, like that. So ammonia, what is the electron geometry? How many electron domains around the center atom in this case? It is 1, 2, 3, 4. 4 electron domains. Electron geometry is tetrahedral. What is the molecular geometry? In molecular geometry, electron like always, if I ask electron, first thing you need to know, electron geometry is one thing. It just talk about the shape of a molecule, but electron geometry is one thing, molecular geometry is another thing. In electron geometry, you count number of electron groups around the center atom. You don't classify them as lone pairs or bonding pairs. You just count the number of electron groups around the center atom. Okay, you tell the structure. But in molecular geometry, you classify them. Okay, this is the electron pair, this is a bonding pair. So I'm asking electron geometry. Okay, I saw, okay, 4 electron domains around the center atom, tetrahedral. In molecular geometry, I know, okay, I have three electron, three bonding pairs. So what are the bonding pairs? So three, 1, 2, 3 bonding pairs and one lone pair. Lone pair is non-bonded to just one bonded to only one atom. See, the bonding pairs always bonded to two atoms. See, it is bonded to nitrogen and hydrogen, but this one only to the nitrogen. So the molecular geometry is you have 4 electron groups, 3 bonded, one lone pair you call trigonal pyramidal. Trigonal. You need to know how to draw these and then how to predict the shape, but I let you have the table with like, okay, basic table with electronegativity, like not electronegativity is like, okay, if you have like 3 electron group, like 2 electron groups, it's linear. 3 electron groups, it is trigonal planar. 4 electron groups, it's tetrahedral. And then 4 electron groups, three, like this particular example, 3 bonding, one lone pairs, it's trigonal pyramidal. 5 electron groups, trigonal bipyramidal. 6 octahedral, and then there electron. So I let you have that table in the exam too. Okay, so let's go back to our no PowerPoint. So now you know what is my expectation. So practice all these given compounds. Draw the structure, draw Lewis structure, how to draw the um, um, how to predict the molecular geometry, how to predict the electron geometry, like that. And then you need to know hybridization. Hybridization also I clearly listed in the um, notes, but I'll give you a cheat or easy one. Oh my gosh. Easy way to identify the hybridization thing is you can easily predict the hybridization by looking at the electron domains. What are the hybridizations? Hybridization, you have um, sp hybridization, sp2 hybridization, sp3 hybridization, sp3d, sp3d2. So all those are the 5 hybridizations you have. By looking at the molecule, how do you predict the hybridization? So, so sp, sp2, sp3, sp3d, sp3d2. So these are the hybridizations. S is a orbital. Remember we talk about s orbital. P is a orbital. So only S and P. When you have two electron domains, so sp means how many orbitals? S orbital and p orbital, right? So it's two orbitals. This is one s orbital, p2, two p's. It's three orbitals. So sp3, 4. This is one s, three p's, one d, 5, 6. So if it is, so orbital means electron domains. So if you have two electron domains, what is the shape? Linear. 3, trigonal planar. 4, tetrahedral. 5, trigonal bipyramidal. And then this is octahedral. Okay, now I'm telling you easy way. So if you draw the molecule, in order to predict hybridization, you need to draw the Lewis structure, you need to identify the electron domains. It's for me, I also predict the shape, and then the hybridization come to the end. You draw the molecule and you notice, okay, this molecule has two electron groups around the central atom, that is linear, goes to the sp hybridization. I'm telling, okay, it's three electron domains around the central atom. It is trigonal planar. Four electron groups. It is it is sp3 hybridization. Um, it is 5 electron groups around the central atom. It is sp3d, like that. So depending on the electron groups around the central atom, you can predict, okay, it is sp, sp2, sp3, like that. If I do an example, carbon dioxide, oh, 1, 2, 1, 2, 2, 3, 4, like that. Oh, 1, 2, 3, 4. Now you see it is two electron domains around the central atom. Two electron domains means you have two orbitals, so it is sp hybridization. You go to ammonia, N12, like that, H, H, H. You have four electron groups, it's tetrahedral, it is sp3. Like that, that's how you predict the hybridization. So if you go back, and then that's so you need to know that that's important concept there. And then you need to identify lone pairs and bonding pairs, and then intermolecular forces, dispersion forces, mm, and then like that. But the important thing is hydrogen bonding. Hydrogen bonding always form like always these intermolecular forces form between the molecules. Okay, it form between the molecules. Example, in order to make hydrogen bonding, like H, let me do it here so I don't want to change it. So let me get a good color. Green colors. Okay, I like this one. Okay, so then I get water. Let me draw water. O, H, and H. So this is one water molecule, and then I'm drawing another water molecule using green maybe. O, sorry, not green. Okay, O, H, H, and then you see the, sorry, 1, 2, 3, 4. There's also 4. And this hydrogen and these is the hydrogen bonding. One hydrogen and oxygen. Always in order to have the hydrogen bonding, you should have one hydrogen. Always the bond has hydrogen and the other one, it should be oxygen, nitrogen, fluorine. So um, these are the other one should be um, because it should be very highly electronegative element. Okay, so what are the atoms participate in hydrogen bonding? You need to know. Okay, that is important concepts. So always it's going to be nitrogen, oxygen, or fluorine should have the other end. Okay. That's it. And then you go. Okay, so you go down and you can see dispersion forces. Dispersion, all the um, talk about the atoms. All the molecules have dispersion forces. Dispersion forces are very minor. Um, but if it is a dipole, what is a dipole? Dipole is when there's a electronegativity between the molecules. It's a dipole. Example, water. Oxygen is very highly electronegative. Hydrogen is less electronegative. So in that way, there's a electronegativity difference. When there's a electronegativity difference, you get the hydrogen bonding. Sorry, it's a dipole, so it's a dipole-dipole interaction. So I have given the hybridization again here. And then next one is balancing equations. Please learn how to balance equations. Okay, that is important. Minimize this. And then you need to know electrolyte, non-electrolyte, electrolytes highly conduct electricity, and you need to know if I ask, okay, always acids and ionic compounds are electrolytes. Non-electrolytes basically molecular compounds like ionic and covalent compounds. Covalent compounds are non-electrolytes. So you need to now identify compound, what is a strong electrolyte, what is a weak electrolyte, like that. And then we did some solubility rules, like solubility rules, like I'm giving you a compound and asking whether this compound is soluble or not. Example, I'm giving you sodium chloride and asking, is it soluble? It is soluble. How do you know? By looking at the solubility rules. I let you have the solubility rule chart for the exam. But you need to practice a little bit before, like, oh, you can at that time, you can just look at the solubility rule. No, you can't do that. So please practice. There's a trend. Always is group one soluble. Group two, like group one means any compound that has sodium, potassium, anything with the group one soluble. Always if the compound has nitrate. What is nitrate? Nitrate is NO3 minus. If your compound has nitrate, it is for sure soluble. If your compound has acetate, which is in vinegar, OCOCH3 minus, it is also soluble. And then ammonium, NH4 plus, again soluble. Anything. So example, I'm asking, okay, predict the solubility of silver nitrate, AgNO3. This is, of course, this is soluble because it has NO3 nitrate. If it is nitrate, it's soluble. Okay, I'm asking another thing. I'm asking sodium phosphate, Na3PO4. Predict the solubility of sodium phosphate. Oh, of course, it's soluble because it has sodium in it because it's a group 1 element. I'm not like I may ask, okay, identify the soluble product and give you 4 compounds for 5 answers. So you have to predict, okay, this is like that. And then identify insoluble product, giving 5 compounds. It's another thing. So another important aspect is you need to know the equation balancing. Equation balancing is very important. And then you need to identify precipitation reaction, combustion reaction. Okay, I'm coming back to the precipitation reactions. Whiteboard, okay. So in the precipitation reactions, what is the precipitation? Two compounds combine and form a precipitate. That is the precipitation reaction. Let me think about one. I don't have anything. Okay, let me take silver nitrate. Silver nitrate is soluble. So I write aqueous. plus sodium chloride aqueous. You will not get this particular one, but I'm telling you the technique. So always in the reactant side, you have to see, okay, both are in the aqueous. What is aqueous? Aqueous phase. That means it's a solution. Uh, and then how do you predict the products? Always, in order to predict the products, this important thing you need to know. Predict the products. You see these. Think about, are these ionic compounds, covalent compounds? Silver is a metal, non-metal. So metal and a non-metal, they are like not a non-metal, it's anionic, polyatomic ion. So this is mm, ionic. Both are ionic compounds. So ionic compound has a cation which is Ag plus, NO3 minus, Na plus, Cl minus. So how it formed the um, so silver goes with chlorine because plus negative. Nitrate goes with sodium. So you get the products. I'm writing products in a different color. I'm getting, okay, it is silver chloride, and these are my reactants, and I'm getting sodium nitrate. Always I know sodium nitrate is aqueous, but silver chloride is solid. So if your reaction two aqueous and form a solid, this is you call the precipitation reaction. Always you should see the solid at the product side. When you have the solid at the product side, that is the precipitation reaction. That is precipitation you need to know. Another type of reaction, there are so many other types, and I'm acid base, and I'm showing you is combustion. Combustion is burning. When burning, it is okay. Um, Burning reactions, it is let me think about it. It's let's say C2H6 combining with, always in burning, like in your level we give oxygen. Oxygen, always combustion need oxygen and gives carbon dioxide and water. Oxygen is a gas, carbon dioxide is a gas, water can be gaseous too, because so this is the combustion reaction. Always you should see, okay, in the reactant side you should see the oxygen, product side carbon dioxide and water. So that is the combustion reaction. Since I have this reaction, let me explain you how to balance this reaction as well. Let me take the balancing in a red color. When balancing equation, first thing is you write the reaction nicely. When you write the reaction, you see two sides, reactants, products, right? Reactants react, and so these are reactants, react and gives the products. So now I'm starting with the reactants. I see two carbons. I see only one carbon. In order to balance, I put two here. And I look at the hydrogen. I have six hydrogens, two. How do I balance it? I put three in front of it. And then I look at, okay, how many oxygens I have 2 into 2, 4, 4 into 3, no, so 2 into 2, 4, and this 3 related to hydrogen and also oxygen, 4 plus 3, 7. So I already have 2 here. So what do? I write a 7 here, but then I multiply whole equation by 2. So it become 2, and then it become 4. Sorry, what did I do? Make it 4, and then it's 6. So my equation now, 2 C2H6 plus 7O2 give me 4 CO2 plus 6 water, right? So now let's see, now it's balanced. It's 4 carbons, 4 carbons. 2 into 6, 12 hydrogens, 12 hydrogens. So let's see, 4 carbons, 12 hydrogens, and then it's 14 oxygen. It's now how many oxygens? 6 and 8. 8 oxygen plus 6, it's 14. So I have this now is balancing. And then so that's about mainly, so equation balancing is another important aspect that you need to know. I have several questions from several questions from equation balancing in the exam. So please practice equation balancing under exam reviews. If I go into your class, I'm sorry, in the exam reviews, you see, if you go to exam review, um, there are certain Chem document that you can practice for exam reviews as well. So I hope this is helpful, and you can get better grade for the exam. Thank you.